On a dark, rainy night, while you were in sleep, a loud thunder and a flash of light wakes you up. Each one of us would have seen lightning. What causes lightning? Lightning is an electric current. But what causes electric current to be created in a cloud? In a cloud, there are several ice particles which bump into each other. This bumping creates electric charge. After a while, the whole cloud is charged. The lighter ice particles are positively charged, and they rise to the top of the cloud, while the heavier slushy mixture of ice and water is negatively charged, and that sinks to the bottom of the cloud. This separation happens due to movement of air and gravity. Due to this huge imbalance of charges, the currents travel across the air to neutralize this imbalance. For the lightning to happen, two conditions must be satisfied. One, two regions that are hugely charged, which in this case are the upper and the lower parts of the cloud. Two, a high resistance medium or a barrier for obstruction, which in this case is the atmosphere or the air. When these conditions are satisfied, this is what happens in the cloud. Intra-cloud lightning. As the charge builds up within the cloud, negatively charged electrons branch out like a tree and form stepped leaders, which move towards more positively charged areas. These leaders break down the air, depositing negative charge and ionizing it. The ionized air has a lower resistance than normal air. Hence, it becomes an easier barrier for the passage of current. Along this leader of ionized air, large currents pass in the form of lightning. A majority of electrical energy, around 80 to 90%, is discharged within the cloud itself as intra-cloud lightning. Intercloud lightning. Occasionally, lightning passes between two separate clouds as intercloud lightning. This form of lightning is dangerous to planes flying around these clouds. However, modern planes have metal frames and electric systems especially designed to deal with lightning strikes. Cloud to ground lightning. The real danger to human life and property is when the negative charge in a storm cloud becomes strong enough to leap to the earth in the form of cloud to ground lightning. We know that electrical charges of same polarity repel each other. So as the negative charge grows in the base of the cloud, they repel the negative charge on the surface of the ground deeper into the earth. This forms a stronger positive charge on the surface of the earth. The cloud's negative charge gets attracted towards the ground's positive charge. Stepped leaders travel towards ground, breaking the air and ionizing it. This ionized air is called plasma. The more the negative charge, the longer the step leaders. The longer the step leader, the more positive the ground. The ground's positive charge follows the path of least resistance and makes fingers, called streamers, traveling towards the negative charge coming from the cloud. When a leader from the cloud meets the streamer from the ground, they create a channel of ionized air for the currents to pass. The two charges meet and the current travels through all the stepped leaders. This causes a flash of light called return stroke. This is how lightning is created. We learned about three types of lightning. Now, some interesting facts you might want to know about lightning. A finger of charge, called a positive streamer, can reach upwards from the ground around 15 to 50 meters in an attempt to join step leaders from the storm cloud. This normally happens just before a lightning strike. The sound of thunder is caused by the same superheated air expanding rapidly and creating a supersonic shock wave. The air around the lightning is super hot. Its temperature can range from 8,000 to 30,000 degrees Celsius. While the temperature of lightning can be about 20,000 degrees Celsius or over 3 times hotter than the surface of the sun, which is estimated to be 5,500 degrees Celsius. It is estimated that the peak power per lightning stroke is 10 raised to the power 12 watts, that is, 1 followed by 12 zeros, or 1000 gigawatts. The total energy in a large thunderstorm is thought to be enough to power the whole of the USA for 20 minutes. Lightning can and does strike the same place twice. On average, lightning strikes the Empire State Building in New York City about 100 times every year. Benjamin Franklin, in the year 1752, is believed to be the first to show that lightning was electricity using his now famous kite experiment. The open oceans do not experience as many thunderstorms and lightning strikes as land due to water's higher heat capacity, preventing the heating of low-lying air, which is crucial for thunderstorm formation. Lightning does not travel straight down to Earth due to impurities in the air like dust, causing it to break down more easily in one direction than another. Research shows that proximity to water, like a pool, lake, or sea, increases the risk of being struck by lightning. Lightning protection equipment is installed to protect a structure or a building from damage caused by lightning. Lightning strikes most frequently in the Democratic Republic of Congo.